All right, for those people following along and paying attention and making sure that everyone likes, shares, and subscribes, especially if you're not in this classroom right now, I go above and beyond to make sure that you have the notes, even though you decide to go to Starbucks every morning and be an hour late. But it's all right though. I'm not calling out anyone in particular. All right, so this one right here, average velocity. Now, if you recall, average velocity, I said it's something specific. Average velocity is the what? Secant line. That means it is a line in between 2 points on my function or on my graph. You did? Oh man, you get a high five. Do I have I don't have high fives, but I do have candy. There we go. See? Got one person admitted to like, share, and subscribing. Anyway, so if S, remember S refers to the position of the function, is equal to f of t, where t is in time, okay, gives the function distance S object travels in time, the instantaneous velocity of the object, v, t sub naught, is defined as the limit of the average velocity, so delta S over delta t as it approaches 0. This is the same thing that we did. If you were in here on the homework, okay, because we just did number 7 from the homework, we actually did the same thing. But we did it as h. We did it, the limit as h approaches. So we're doing the same thing, they just look slightly different every time. But from this function right here, this is actually getting t close to 0, so it's actually going to be right at that point. And so right here, that is provided that the limit exists. So, given that much information, find the velocity of the falling rock of the previous example. Ooh. Okay, velocity. Here it is right here. I had my function f of t equals 16t squared. Now we're going to do some voodoo. Because this is my position. My first function is my position. So this is actually really important. So S refers to the position that it's at of my function. Now, when I take the derivative of the position, I'm going to have to write it in a couple different ways. That would be my v, that's my velocity, which is the same as saying f prime of t and so f prime of t. So I'm going to do the voodoo for those people that you do. Voodoo? Anyway, all right, so here's the voodoo. Exponent is what? 2, right? What do I do with the 2? The 2 goes out front, multiplies out front, right? So 2 times 16 is 32. Now, I still got my variable t, right? But what do I do with my exponent now? Minus 1. Because I use that right there, so it's going to be just t. So it's minus 1 like that. And so this is the equation for the velocity. At any given point. That's the velocity at any given point. So my first one is, okay, let's find the velocity at 1 second. So this thing, it fell off the bridge 1 second later because we know that it is accelerating to the point as it's going to hit the ground and goes flat. So let's do the velocity. So that would be a v of 1 second is equal to 32 times 1. And so this is my velocity. So velocity I always try and do this. This is actually one thing that I do that in this case it's not right. But whenever I hear the word velocity, I think of miles per hour. The reason why I do that for velocity is I trick myself into always thinking miles per hour is distance over time. Miles over time. Okay? And it has to apply to this problem right here now. So if it's applying to this problem, so instead of miles, what do we have on this problem? Feet per second right here, right? So miles per hour, feet per second. One of the objectives on the test is you do not get full credit unless you have the units correct. So that's important. Next one. T sub naught, so that's my velocity. Okay, 7.4 seconds, just before it hits the Colorado River. So that means I'm going to do V of 7.4 is equal to 32 times 7.4 is going to give me about all right, do I need to go back and do the math? I just noticed 32 times 1? Yeah, okay. So can you multiply those out? I don't know my 32 times table, so. We're all staring at each other awkwardly. I'm hoping someone actually does this math for me. You can stare at me awkwardly, I'll stare right back. It's super awkward, right? Or you can just put it in the calculator for me, because that's kind of what I'm waiting for.
$236.8.
236.8? What are my units? Feet per second. Wow, that's actually going pretty fast. So that's right before they hit, right? When we did the problem the other day, we said that the average velocity from start to finish was 119 feet per second. Average is my starting and my ending, add them up, divide by 2 basically, right? That's how I figure out the average. And we said, okay, right here, when it hits, it's going this fast. So at the very beginning, when it's going just 32 feet per second, and then at the very end, it's going to 236.8 feet per second. That makes a big difference, right? So yeah, that's going fast. That's going hard. Okay. Last time, the last one, C. At any time. That's why we did the Voodoo Magic. Voodoo Magic gives me the equation right here. F prime of t, which is my velocity, which gives me this equation right here. All I have to do is plug in for any time. Yes, no, maybe, possibly. Is that the last problem? Do we have more? Oh, hey, look, the same thing that we did. So I just introduced this sooner. Let's try this one. This one's actually pretty quick. Find the derivative. So let's do the voodoo. So if that's the function, f prime of x would equal voodoo, which is going to be 2 times 2, which is 4. 4 what? X minus 3. What do I do with this thing right here? Goes to 0. If there is no variable and I'm subtracting 1 from the variable, if there's no variable, then it just goes to 0. Okay? I believe I actually graphed this to show why that's like that. I did. Do you remember me graphing it?
I think so, at least.
Yeah, I drew a horizontal line and I said, all right, here's this right here at -2. What's the slope at -2? Yeah, just 0, right? Okay. So there we go. So now we have the equation for my velocity, my derivative. So from right here, let's go ahead and do f prime of 2. So f prime of 2 is equal to 4 times 2 minus 3, which is going to give me 8 minus 3 is 5. Now, in words, someone explain it to me in words what this means. What does this part right here mean?
And x equals to the slope of the tangent line.
The slope, right? The slope of the tangent line at is, there we go. So that would be a very good thing to write out, especially because you have to explain it several times in different problems. Is that the last one? Nope, it's not.
I hated this.
Oh, hey. Given interpretation, derivative, right here, slope, rate of change. Okay, distance of the time, okay. Oh yeah, it's everything. So I got it all. Now this one right here, I like this one. Okay, I like the voodoo. So I'm gonna rewrite this function. And so instead of saying that, isn't that gonna be the same as isn't it the same as that? They're inside the radical, so 2x, it means 2 times x, so inside the radical, that means that those two are being multiplied. Okay, now I'm gonna rewrite it one more time because I don't like radicals. I really don't. I don't like radicals, so I'm gonna rewrite it one more time. With a fractional exponent, in my fraction, my top number is the power, the bottom number is the root. So if you were to write it like this, and this is going to actually make your life a whole lot easier because we have a lot of this stuff. By rewriting it like this, it's going to help out. Now that it is slightly simpler, can I do some voodoo magic? Say yes. I can do the voodoo magic from here. My exponent is 1/2. What do I do with that exponent? What do I do with my exponent? Out front, right? I multiply it by out front. So that's going to give me 1/2 times rad 2 is rad 2 over 2. Yes? Hopefully. Now, what do I do with my exponent though? I need to do what? Subtract 1, but I'm subtracting 2 over 2 because I like having common denominators. And isn't 1 just 2 over 2? And now when I subtract that, do I get negative 1 over 2, right? But also, I don't like negative exponents, so I kind of fix that. What do I do with it to fix the negative exponent? Where does it go if I have a negative exponent? It goes on the bottom, right? And moves across the divisor right here, and it goes to the denominator. So by doing that, it's going to be rad 2 over 2, and then I'm going to put that in there, so it's going to be, again, positive x to the 1/2, or x to the positive 1/2 there. So now, this right here is the equation for the slope. I have the derivative now. At 8. Now we can plug in 8. So that means that I'm going to have f prime of 8 is equal to rad 2 over 2, and that's going to be 8 to the 1/2. And square root of 8. Should I go off to the side to do that one? Yeah? Okay. So, square root of 8 is the same as saying square root of 4 times square root of 2, right? Okay, I like simplifying it, and I like finding perfect roots in there first. So that's what I always try to factor it to be something that's perfect. So we know the square root of 4. Square root of 4 is just 2, and then I still have that rad 2 left over. So this is going to be 2 rad 2. So square root of 8 is equal to 2 rad 2. And so if I put that back in there, it's going to be rad 2 on top, 2 times 2 rad 2. And since all that is being multiplied, what could I do with those rad 2's? Can I cancel them? I like canceling. I do. So in words, right here, the slope of the tangent line when x equals 8 is 1 over 4. And it says, part B, use that to find the equation at 8, 4. So I'm going to use point slope. Y minus 4 equals 1 over 4, quantity x minus 8. Do a little bit of distribution. Y equals 1 over 4 x minus 2 plus 4. Alrighty, let's go ahead and y equals 1 over 4x plus 2, and this is the tangent line. Now, I don't want to push through the rest. We can pick up the rest of it tomorrow, and then I want you guys to have some time practicing this today, and then we'll finish the rest because I feel like we're pushing through anyway. I don't want to do that, especially for this one right here. The tables are important because that's a huge portion of the test is figuring out tables and reading tables. So make sure you guys all like, share, and subscribe.